The 10-kilogram collar is released from rest at its origin O with the height of H 120 centimeter, as shown in the figure. It then slides down the fixed rod OD with negligible friction and a long section DE with the coefficient of friction of 0.25 after hitting the spring. Right at this instant, the expression for the speed of the collar at point B and D. The maximum deflection of the spring, knowing that the spring with K equal to 1.2 kilonewton per meter is initially unstretched. Draw the illustrative diagrams clearly and see the time taken from B to D. We have a collar here, released from stop. So the only force that applies to this collar is its own weight. It will slide along this rail without friction. But once it touches the spring at D, there will be friction. Let's focus on the question A. We want to calculate the speed of the collar when it reaches point B. We are going to apply work energy method. Kinetic energy at zero. It is zero because the velocity is zero. It is released from rest. At B, the velocity is unknown. We have the mass. So half mvp square, it becomes 5 vb square. So we have the weight. The weight is always vertical downward. The weight will lead this roller to move vertical and then follow this curve. In terms of displacement, parallel to the direction of force is only h plus this radius, 96 centimeter. It doesn't matter that it goes to the right by 96 centimeter. So that is the weight. So that is the distance parallel to the weight in the direction of the weight D. So the work will be that W times that D. So that's the only work that we have. We go directly to the work and energy principle. O plus the sum of work from O to B equals TB. We put all the equation that we obtained previously. From here, you can obtain VB. 6.61 meter per second. Now we go to point D. The speed of the collar at point D. Let's see from B to D. From B to D, the collar will move horizontally. The force on the collar is still its own weight, vertically. So we have vertical weight, but the displacement horizontal. The work will be zero because there is no force parallel to the direction of displacement. Since there is no friction between B and D, so velocity at D will be the same with B. We have VD equal to VB. Now, question B. It starts to touch the spring at D, then it will push the spring. The spring will give opposite force. The work will be negative because the displacement is to the right, but the force from the spring is to the left. Initially D, and the final I put F. So this is about displacement from D to F. The velocity at D is going to the right. So the kinetic energy is, you just calculate the velocity at D, you know previously. At F, it stopped. No more velocity. The kinetic energy is zero. Now we are going to calculate the work. For that, let's focus on the collar touching the spring. That is the displacement. We have the force from the spring. Since the collar pushed to the right, the spring will push to the left. It means we have negative work. Since the collar moves to the right, the friction will be to the left. Those are the two forces parallel to the direction of displacement. The friction depends on the normal force. The normal is the reaction from the wall of the rod to the collar. And the normal is opposite to the weight. The work due to contraction of the spring equal to half kd square. You put negative because the direction of the force is opposite to the direction of displacement. We have the work from D to F due to friction. The friction is going to the left, the displacement to the right. So again, we have negative work. Friction is mu times N. Mu is the friction coefficient, 0.25. N is the reaction from the floor, which is in this case equal to W but opposite in direction. So we have 98.1 Newton. You have the work from 1 to 2 due to the friction. So you calculate the total work. So you have the work from the spring plus work from the friction. Then you apply the work and energy principle, just like this one. So you can rearrange this one to have a quadratic equation. There will be two answers, D1 and D2. You have one is negative 0.62, one is positive 0.57. We have a convention that positive displacement is when it is going to the right. When it is negative, it means the spring is going to the left. Absurd, because the collar is pushing, it cannot extend the spring. So it means this value is not valid. This one, it will be the answer. Finally, last question. Time taken from B to D. From B to D, the collar moves with a constant velocity, Vb or Vd. The distance from B to D is 2.1 meters. From there, we can calculate the time taken for the collar to travel from B to D. We obtain 0.32 seconds.